So fractions, but more particularly algebraic fractions. Always factorise first. Before you do anything with algebraic fractions, you factorise. Then once you've got that, yeah, I didn't know the words to write down for this, so I just went, but only cancel complete, not bits of them. You see, we love cancelling. Oh, there's an X, there's an X, there's a... Can only do it if the is the same, whatever we call that. Let's do one. Well, this one here is just a single term on top and bottom, so we're just looking for things that cancel. So this one we can go, oh yeah, this goes into this and so on. And of course we end up with 2a squared on 3bc squared, the first type of algebraic fraction that we saw. On the top we have a common factor of a, on the bottom there's a common factor of 2a, but hang on a sec, I can keep going on the top, I've got a difference of 2 squares. All right, we're now fully factorised, we can cancel. Now clearly the a will go with the a, but we have the same p minus q, which will cancel with p minus q. So we're just left with p plus q on 2. And if we were doing that parametric topic, I would say the average of the parameters. But of course that means nothing to you at this stage. Let's have a look at this. Oh boy, multiplying two fractions together. Oh geez. Whenever you're multiplying two fractions together, what's the first thing you do? I'll give you a hint. Oh, well done. Okay, factorise. So let's see. Well, the x plus 1 and the 3x plus 1 can't factorise, so we just put the parentheses around it. There's one of our... We've got to come up with a name for that. So now, which one did I do next, you reckon? The difference of 2 squares or the trinomial? Well, which one would you do next? Yeah, I'd go with the difference of 2 squares. It's probably going to be the quicker. Yes, I did. Oh, look. I am allowed to contradict myself, okay? Yes, the plus is first. 3x plus 1, 3x minus 1. Now, our quadratic trinomial on the bottom. Beautiful thing about that one, it ends in 1. 1 is... What's good about 1? So it makes it easy to factorise. 1 is... Oh, good, no one's going to say it. I was just waiting for someone to say it's a prime number. But of course, 1 is not a prime number. However, there is still only one factor we can use here. So we know it's going to be 1 and 1, makes it nice and easy. We just got to work out where the negative goes. 3x minus 1, x plus 1. Then we start cancelling. Mind you, let me just go back a step. Look at this. If I had to guess what the factors are on this, just because I know how people set up questions for tests and things like that, be careful though, have a look at it. And you go, oh look, the 3x plus 1 cancels with the 3x plus 1 at this stage. Yeah, it's probably a strong chance that what I'm about to factorise is going to be 3x minus 1, x plus 1. Oh, what a surprise, there it is. Okay, now we cancel, and everything cancels. So we're left with, and don't put down 0, okay? I have seen that. Everyone cancels, well, nothing left, nothing left. You know. Algebraic fractions and division. Because division with fractions is different. When you have a division, because division and fractions is tricky, so we don't do it. So what's the first thing you do with one like this when it's a division with fractions? Anyone? Sorry, what was that? Flip the fraction? No. What's the first thing you do? Thank you. Factorise. You always factorise first. But you are right. I actually do it in 2 steps and go, yeah, let's flip it as well. So we flip it, or invert and multiply to use technical names. Now let's factorise. Oh, which one would I have gone with? Oh, look, top of the first one. It's just common factors, isn't it? There we go. Then we've got a squared minus 4ab plus 4b. Is that a perfect square? It is, isn't it? There we go. A minus 2b all squared. Now we can cancel, and we're left with 1 over 2a, a minus 2b. Okay. Subtraction. Oh yes. You can't just subtract fractions easily. You know, half minus a third. So before we can do our fractions, what have we got to do first? Very good, we're catching on. We always factorise first. So let's do that. Okay, it's quite an easy one there, just common factors on the bottom. On the top, we just put our parentheses around them. Now comes the key bit with additional, subtraction and fractions. What do we need? A common denominator, yes. Why? I know it's been drilled into you, probably in primary school. Was that the first time you see fractions with numbers? But why? Did I actually ever explain to you why? It is just a lot easier to compare when the denominators are the same. And that's why we do it. It's simply for comparison's sake. Okay, how do we work out our common factor? Well, there it is. A minus 1, a plus 1. How do I do it? That's how I do it. If it's not there, put it down. Simple as that. If it's not there, put it down. So I work my way from left to right. I start and I go, A. It's not there. So I put it down. A. I then keep going. A minus 1. Not there. So I put it down. Move to the next fraction. A. Oh, it's there. Not a problem. A plus 1. It's not there. So I put it down. There's my denominator. Okay? That's how I always do it. And that way, I mean, it would have been possible, some people would have just multiplied the two together, but you end up with a squared. It will still work. It just means later on, you're going to have to do some cancelling. So it just saves time to get that out of the way first. If it's not there, put it down. Now I've got to work out what goes on top. And that's when I say to myself, what's different? So I look at the first fraction. Its denominator was a minus 1. It's now a minus 1, a plus 1. What's different? It's not a trick question. Spot the difference. A plus 1. So that is what I multiply the numerator by. So we get a plus 1 squared. Minus, now we do the same thing. It was a plus 1. It's now a minus 1, a plus 1. What's different? A minus 1. So we'll go minus a minus 1 squared. Okay. Of course, we can't cancel yet. Why not? Because before we cancel, what do we have to do? Factorise. Always factorise first. See, we've broken the factorisation. It's no longer factorised on the top. So now we've got to factorise it before we cancel it. There's a quick way of doing it, and there's a long way of doing it. There's the long way. Expand the whole thing out and then tidy it up. The quick way is to do this. I have a perfect square minus a perfect square. The terms are basically the same. One's a plus, one's a minus. I know that when I expand out a perfect square, I get a squared, 2ab, b squared. So if I'm subtracting, the a squared and the b squared is going to disappear. But I'll have a 2ab minus a minus 2ab. I should end up with 4ab. So 4ab would be 4a times 1, which is 4a. Use patterns to your advantage. If you spot it, it's going to be quicker. Okay? Patterns is what maths is about. In fact, human beings are naturally drawn to patterns. We like things to be symmetric, things like that. Right? Look for the patterns. Still some cancelling. The a's will cancel, 4 and a minus 1, a plus 1. All right, 3 fractions. This is fun. Oh, but they've already factorised the first 2 for us. Got to factorise the last one now. So let's do that. Okay, we need a common denominator. If it's not there, put it down. There it is, because the way we would do this, x plus y squared, not there, put it down. X minus y squared, not there, put it down. X plus y, well, it's there, it's inside the x plus y squared. Whenever you've got that situation, you have to have the highest power. 2 is the highest power, so that's the one that's required there. X minus y, same situation, we need x minus y squared. What's different? Was x plus y squared, it's now this. I have to multiply the top by x minus y squared. Move to the next one. X minus y squared, what's different? X plus y squared, write that down. Minus 2 lots of, what's different? I need those factors repeated to make it squared, so it'll be minus that. The long way of doing it. There's nothing wrong with the long way, by the way, it just takes a little bit of time. It'll work. The quick way of doing it. Perfect square plus a perfect square. Similar to the last one, but now it's the 2 ABs that are going to disappear. I will end up with 2x squared and 2y squared, but I'm going to take away twice the difference of 2 squares, which would give me x squared minus y squared, but I'm subtracting that, so the 2x squared minus the 2x squared goes. That leaves me with the y squared, the 2y squared minus, it should be 4y squared, shouldn't it? There it is, 4y squared. Done. Look, if you find yourself making mistakes trying to do that all in your head, then okay, write another line. The more you try and do in your head, the more chance of a silly mistake. So if you find yourself making silly mistakes, then okay, use another line and get there. All right.